down to the down to the workpiece.
Okay.
Makes a touch. Then goes up to the electrode length. Shoots out the electrode, and then the working process starts.
Okay.
Okay.
Okay. So it has to go up, huh?
Has to go up, makes a second touch with the electrode on the workpiece.
Okay.
Then it starts to work.
You can record me a bit.
Sorry?
You can record me.
Yeah.
David, it is recording. I think you can see now what you see.
Yep, we can make it a little bit. Could you shut down the light? Then we can see it.
Oh, it's too dark. It's too dark. But today I think you can see it clearly. Oh, you have stopped, eh?
Now it goes to the controlling point. Makes a touch.
Oh, it is next.
The tool wear. Now it shoots out the electrode again. Now you've heard the short circuit. When it touches the surface.
Okay.
And after that, it continues to work.
If in a case of a short circuit, it means?
No, that was not by accident.
Not by accident.
No,
Yes.
the electrode
Has to touch.
Shot out.
Okay.
Of the clamping system.
Okay.
And when the electrode arrives on the surface,
okay,
then you have a short circuit.
Okay, but that is not, it is not a problem.
That's
here.
Normal.
It is normal.
Yeah.
So it is right. It wanted to start.
That's just for shooting out the electrode.
Okay. Okay. I get the point now. This is a microscope whereby you can see the through of about 100 or 300 microns.
That's the next control.
Oh, after one control, it has to stop. After
it has to stop to make control.
To make control.
Yeah. Now you've seen that the electrode was shot out again. Then it goes down till there is a short circuit. Right now, when you hear that beeping noise, there is a short circuit. Then the machine knows that the electrode is on the surface. Sets the 0 position.
Okay.
And then it continues to work.
Okay. But if it is a short circuit, it shows 0, 0. When here it shows 0, it is a short circuit. But it has to give a signal. If it is a short circuit, it gives a signal. Eh?
This short circuit is caused by the touch the electrode
of the electrode to the
okay.
Okay.
And when this touch is done, all the axes are set to 0, 0.
Okay. Okay. But the problem, I find if it goes to 0, 0, it has to stop the machine and it starts. Every time if it touches, it will stop the machine and it starts. But it was not the case for the first.
No, but that is wanted. That's what we want.
Okay.
We want the machine to control the electrode length.
Okay.
And for that reason, it has to stop the process.
Okay.
Control the length of the electrode.
Okay.
To shoot it out.
Okay.
So you have a longer electrode length. Okay. Then you have to make a touch on the workpiece. Okay. And then you continue with the work.
Okay. Because for the first experiment, we have used it to control like 3 times the 2 lengths. Okay. For this one also it is for 3 times. Yeah. But for the first experiment it was not stopping. I don't know.
It was not stopping.
I don't know because I find it was not. It seems that it was not stopping.
Perhaps.
Because here it is stopping.
I didn't
remember. Yes, we didn't. Yeah, because you find it now it is stopping now. Yeah.
Because right here you can hear it exactly when it's stopping. Because it's very loud.
And this is not 0 now. It is about.
Now the electrode goes down. You see the set. Parameter goes down until the 0, 0 position. Make the touch.
You can start this to see what.
I had to change the spin.
You have to change it. Okay.
It's not.
You didn't.
Working now.
Okay. But this is like because the gap voltage now it is about 100. 100.
Yeah.
Because we didn't change the parameter.
No.
Okay.
Right here you can see.
Yeah. But what is the type of oil we are using here?
This is I don't know exactly. But I know that it's oil-based dielectric.
Okay, dielectric.
Tell you more about it. Oil, the electric oil. I don't know the exact chemical.
Maybe it is a petrol, a petroleum oil.
But I can ask that.
Oh, okay. Because it is not connected.
No, it's not connected.